Okay, lesson 73 is about formulas for sequences. You've got your objective here. Let's go ahead and get started. Example 1 says to find the 8th and 9th terms of the sequence generated by this formula. Okay, so I'm going to rewrite this formula. And remember, we learned about sequences a few lessons back. Okay, and remember, this n stands for the term number. Okay, so we want the 8th and 9th terms. So all I'm going to do is say that the 8th term, this is the notation for the 8th term, is equal to 3 times, and we're going to put 8 in for n, okay, because we're replacing this n with 8. So we do the same thing here. So the 8th term is 24. So that's the 8th term, is 24. Then for the 9th term, we're just going to plug in 9 for n. So it's a 9, that's the notation, and we're going to take 3 times 9, and that equals 27. So that means the 9th term is equal to 27. So again, the nice thing about these formulas for the sequences, if we can make a formula, is that all we have to do to figure out any term number is plug that number in for the variable. Okay, so for example, we want the 100th number. We would just plug in 100 and get 300, okay, for our answer. Let's go ahead to the next slide of examples. Example 2 wants us to find the next two terms in each sequence. Well, first thing I'm going to do is rewrite the sequences they give us. So we got 2, 4, 8, 16, 32, and then we want the next two terms. Well, easiest way to do this when we have a list like this to figure out the pattern. Well, the pattern here is pretty easy to see. I'm going times 2 in between each one. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, and so on. So if I'm going times 2 between every one, I need to keep that going. Do times 2, and 32 times 2 is 64. And multiply by 2 again, and 64 times 2 is 128. Okay, so my next two terms are 64 and 128 for part A. Okay, so for B, we've got 1, 1, 2, 3, 5, 8. Well, this one's not as straightforward, so the first thing I would do is see, am I adding the same thing in between each number? Well, 1 plus 0 is 1, and if I add 0 again, that doesn't give me the next term. Okay, or multiply. Do I multiply by the same number? Well, 1 times 1 is 1, but then if I multiply by 1 again, that doesn't give me 2. So, there's no straight up pattern to this one. So we have to try to figure it out. So we have to use some problem solving, some reasoning here. Well, if I look at this term and that term, let's say I added those together. 1 plus 1 gives me 2. Then if I added this term and that term, 1 plus 2 gives me 3. And 2 plus 3 gives me 5. And 3 plus 5 gives me 8. So to get the next term, I'm just adding the two terms before it. So 5 plus 8 is 13. And 8 plus 13 is 21. So those are the next two terms. Alright, and C, let's go ahead and write this one down. 1, negative 2, and then 2, and negative 1, and 3, and 0, and 4. Okay, so again, this one doesn't look like the same thing's happening every single time. Okay, well, I could go by multiplying here, and multiply by negative 2, but then how do I get back to this one? Well, if I go times negative 2 here, I multiply times negative 1. And then if I went times negative 2 again, then that wouldn't work. Okay, so let's figure out, let's say here, between 1 and negative 2, I am subtracting 3. Or adding negative 3. Then from negative 2 to 2, I'm adding 4. Then from 2 to negative 1, well, I'm subtracting 3 again. And from 1 to 3, I'm adding 4. Sorry, from negative 1 to 3, I add 4. From 3 to 0, I take away 3. And from 0 to 4, I add 4. So I think I've got our pattern figured out here. We're going to take away 3 next, so 4 minus 3 is 1. Then I'm going to need to add 4 to to the pattern. And 1 plus 4 is 5. So my next two terms are 1 and 5. Now, problems like this, you just need to try to figure out what the pattern is, okay, with some problem-solving skills, and then find the next two terms. And let's go on to the next slide. This says to find the first three terms of the sequence given by the formula. So again, I want the first term, the second term, and the third term. Okay? Well, again, all that means is I'm going to plug in a 1 to figure out the first term here. So I'm going to have the first term is going to equal 1 plus 2 times 1. Because that's what 2n means, is 2 times 1. Well, again, order of operations. Do I add or multiply first? We should know I multiply. So I'm going to have 1 plus 2 times 1 is 2. And that equals 3. Okay, so my first term equals 3. For my second term, I'm going to plug a 2 in. I'm going to take 1 plus 2 times 2. Now that equals 1 plus 2 times 2 is 4. And 1 plus 4 is 5. So now my second term is 5. And my third term, we're going to have the third term is equal to 1 plus 2 times 3. Again, all I'm doing is plugging in the term number I want for the n value here. And now I'm going to solve it. That equals 1 plus 2 times 3 is 6. And 1 plus 6 is 7. So the third term of the sequence is 7. Okay, so there's the first, second, and third terms. And all I did was I plugged in the number of the term for this variable here. So for the first term I plugged in a 1, for the second term I plugged in a 2, and for the third term I plugged in a 3. That was it, and then solved. Alright, and let's go to our last slide of examples. Okay, example 4 says the numbers in this sequence are sometimes called triangular numbers. So if I look at this sequence, 1, 3, 6, 10, 15, okay, they're called triangular numbers because I can arrange their dots, except for 1, okay, I can arrange their dots to form triangles. So I can arrange 3 dots to form a triangle, I can arrange 6 dots to form a triangle, and 10 dots to form the triangular, and so on. Okay, and all the numbers that you could possibly do that with, all the triangular numbers, are found using this formula right here. Okay, and I want to find the 10th triangular number. So all I'm going to do, if I want to find the 10th number in the sequence, is plug in a 10 for my n values here. So I've got the 10th triangular number, that's the notation, should be equal to, and then I'm going to plug in a 10 every time I see n. So 10 times, I see another n here in parentheses, so it's 10 plus 1 all over 2. We do PEMDAS, order of operations, so we do parentheses first. So on top I'm going to have 10 times, and in parentheses 10 plus 1 is 11, all divided by 2. And again, we've got a fraction bar, so I need to figure out the top and the bottom separately. Well, the top, 10 times 11 is 110, divided by 2. And 110 divided by 2 is 55. So 55 is the 10th triangular number. That means I should be able to arrange 55 dots in a triangular pattern like this. And that's your lesson on using formulas for sequences. Best of luck on the homework.